In the vast darkness of space, a powerful system of planets, moons and mysteries revolves around a single star. 8 planets, countless moons, endless mysteries. What secrets are hidden among the planets orbiting our Sun? Billions of kilometers wide, filled with planets, asteroids and cosmic wonders. Welcome to the Solar System. Today, we explore the wonders of the Solar System. Welcome to Random Channel. If you're new to the channel, don't forget to subscribe and turn on notifications to receive regular updates. I hope you enjoy the video. The Solar System consists of everything under the influence of the Sun's gravity, including the Sun itself, planets, moons, asteroids, comets, dust, and gases. If we were to observe the Solar System from outside it, we might say that it consists only of the Sun. This is because the Sun represents over 98% of the Solar System's total mass. After the Sun, the largest object in the Solar System is Jupiter, which has a diameter 1/10 that of the Sun and a mass less than 1% that of the Sun. We have been studying the Solar System from Earth for hundreds of years, but the problem is that for most of this time, we didn't know that it was spherical. However, the ancient Greeks knew this and provided measurements very close to those we have today. Most people believed that the Earth was stationary and didn't move. When researchers like the Greek astronomer Aristarchus of Samos proposed that the Earth wasn't stationary, people ignored their ideas. From their perspective on Earth, the idea of the heavens rotating around the Earth was very clear to them, and this theory was later supported by other sources. Great thinkers like Ptolemy and Aristotle dominated, overshadowing other ideas from lesser-known thinkers like Aristarchus. Ptolemy's geocentric model remained dominant for over 1,000 years until 1543, when astronomer Nicholas Copernicus published his research proposing a heliocentric model. This was the same idea that Aristarchus of Samos had proposed nearly 2,000 years earlier. However, Copernicus's heliocentric model had some problems, primarily its inability to accurately predict planetary motion. This problem was solved a few years later when Johannes Kepler presented his theory that planets revolve around the Sun in nearly circular orbits. This challenged the previously held belief that planetary orbits were perfectly circular. Soon, the general public's understanding shifted to a heliocentric model, paving the way for Isaac Newton to apply physics and calculus to the Solar System. This study aimed to determine how gravity works and has led to our current understanding of how the Solar System functions. The Sun, the largest object in the system by a considerable margin, possesses the strongest gravity and thus governs the movement of the entire Solar System. Regarding the planets, we must be careful when applying this term. Using it indiscriminately would be inaccurate because the term planet has no defined limits. We could apply it to any other object. Does a planet become a planet only when its size allows it to be spherical? There are many spherical moons and asteroids. Or is a planet defined by its satellites and moons? Venus and Mercury don't have moons, but they have many asteroids. Therefore, a planet must be massive. However, Jupiter's moon Ganymede is larger than Mercury. Does this mean we should consider Mercury a planet? The list of questions on this topic goes on. All of these planets orbit the Sun in a flat disk, not randomly. The 4 inner planets, Mercury, Venus, Earth and Mars, are relatively small and stony. The outer planets, Jupiter, Saturn, Uranus and Neptune, are much larger, heavier, and have denser atmospheres. The asteroid belt, composed of billions of objects of varying sizes, lies between Mars and Jupiter. Beyond Neptune's orbit is the vast Kuiper belt, which contains a collection of icy bodies. Both of these belts orbit the Sun on the same flat disk as the planets. However, if you travel farther from the Sun, to a distance of tens of billions of kilometers, you will reach the Oort cloud. The objects there do not orbit the Sun in the same plane. Their orbits are random. The Solar System forms a disk because it rotated at an incredible speed during its formation, much like pizza dough being rolled out in the air. During the formation of the Solar System, the 4 inner planets could not retain much gas due to their proximity to the Sun. In contrast, the outer planets were able to retain more gas because they are larger and cooler due to their greater distance from the Sun. These gases, especially the lighter ones like hydrogen and helium, have grown so enormous that their mass now exceeds that of the planet's solid mass, transforming them into gas giants. These details are not mere abstract theories, Mathematics and physics support them. Despite all that we have learned about our solar system, it is just one of billions in the universe. The names of the planets in our solar system are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But that's not all we know about them. The solar system contains a staggering number of amazing facts and curiosities. For example, Mercury is the closest planet to the Sun, and its year is only 88 Earth days long. Due to its high orbital speed, ancient civilizations believed there were two planets, one visible in the morning and the other at night. Although Mercury's year is short compared to Earth's, its rotational period of 1 day is very long. 1 day on Mercury is equivalent to 58.6 Earth days. Due to its small size and weak gravity, Mercury lacks an atmosphere to protect it from solar radiation. This allows the surface temperature to reach 430 degrees Celsius and drop to minus 170 degrees Celsius. Mercury's surface is very similar to the Moon's, with many craters. The largest crater is the Caloris Basin, estimated to be about 1,550 kilometers in diameter. Venus, the second planet from the Sun, is the hottest planet. Contrary to popular belief, Venus's temperature is higher than Mercury's. The reason for its higher temperature is its extremely strong atmosphere. Venus's atmosphere is about 93 times stronger than Earth's, resulting in a massive greenhouse effect on its surface. This is why the temperature on Venus reaches approximately 460 degrees Celsius year-round. Incidentally, this temperature is enough to melt lead. Sulfuric acid rain also falls constantly on its surface. The first spacecraft to land on Venus was Soviet in 1970, but the mission failed because it melted due to the high temperature. However, before melting, the spacecraft managed to send back pictures revealing that Venus is geologically active and has 1,600 volcanoes. In 1900, a competition was established offering a valuable prize to the first person to discover life on other planets. However, Mars was excluded from the competition because at the time, it was not believed to be a planet. Because Mars has life, scientists wanted to search for life on other planets besides Mars. Even more surprising, in 1938, director Orson Welles created a radio drama inspired by the famous story, The War of the Worlds. The program caused a sensation because people believed it was real, and that beings would descend from Mars and conquer Earth. Although Mars is much smaller than Earth, it has the highest volcanic peak in the solar system, reaching 27 kilometers. This peak is Olympus Mons. Mars has seasons similar to Earth's, because its axis is tilted similarly to Earth's. Satellite imagery has also revealed empty channels and canals carved into Mars's surface, which is surprising. This suggests that water once flowed on the planet's surface. However, because its atmosphere is weak, intense solar winds evaporated all the water. This theory is supported by the presence of water at the planet's poles, though it exists in the form of the largest storm in the solar system, the Great Red Spot on Jupiter, is composed of ice and contains a high percentage of carbon dioxide. It is so gigantic that it could swallow 2 Earth-sized planets. The storm rises 8 kilometers above the clouds, with wind speeds reaching 800 kilometers per hour. The storm produces a sound loud enough to deafen an adult. The strange thing is that no one knows when or how the storm began because it was already present when Jupiter was first observed. It's not just a massive storm, it's likely the source of all Jupiter's heat. Scientists are baffled by Jupiter's surface temperature. Despite being 5 times farther from the Sun than Earth, Jupiter has temperatures similar to Earth's. This is just one of the many mysteries surrounding the gas giant. Saturn is most distinguished by its rings, which likely formed around the time the Sun was born about 4.5 billion years ago. Cassini discovered that the rings formed relatively recently, possibly when dinosaurs roamed the Earth. Scientists theorize that the rings formed from an enormous icy comet from the Kuiper Belt that became trapped in Saturn's gravitational field, eventually disintegrating due to the planet's immense gravity. Interestingly, if a comet were to approach Earth, our planet might be able to trap it with its gravity. The comet would then disintegrate and form rings around Earth, similar to Saturn's. While the scene would be beautiful, the sky would constantly rain destructive meteors. Titan, Saturn's largest moon, is the second largest in the solar system. When the Huygens probe landed on Titan in 2005, scientists found that its landscape and terrain are similar to those on Earth, containing river basins, oceans, and plains. The Moon also has a remarkable atmosphere. Although these characteristics make colonizing Titan a viable option, it is devoid of oxygen. But it's very rich in methane gas, which pours down on it like rain. Uranus is the 7th planet from the Sun and the 3rd largest in the solar system. It was discovered in 1781 by William Herschel. Similar in composition to Jupiter, Saturn, and Neptune, it is classified as an ice giant, consisting primarily of hydrogen and helium with a higher proportion of water ice and methane. Uranus's atmosphere is the coldest in the solar system, with temperatures reaching -224 degrees Celsius. One of Uranus's most notable features is its ring system, which is similar to Saturn's. However, the most peculiar characteristic of this planet is its axial tilt. It is tilted at the same angle as it orbits the Sun, meaning the north and south poles are located at the same point as Earth's equator. This results in continuous summer and winter on Uranus's surface lasting up to 42 years. In 1846, scientists observed irregularities in Uranus's orbit and hypothesized the existence of another planet beyond it. This hypothesis was later confirmed by the discovery of Neptune. Like Uranus, Jupiter, and Saturn, it is a gas giant planet. It completes an orbit around the Sun every 165 years, and one day on its surface is equivalent to 16 hours on Earth. The distance between Neptune and the Sun is 30 times greater than the distance between Earth and the Sun. Due to its cold clouds, the planet's temperature reaches -220 degrees Celsius. Neptune is known for its blue colour, which is due to its abundance of methane gas. Its largest moon is Triton. Unfortunately, this moon experiences powerful gas explosions that rise hundreds of kilometres due to Neptune's strong gravity. For this reason, it is predicted that Neptune will destroy Triton in the future. The Sun itself is a wondrous universe, accounting for 99.98% of the mass of the entire solar system, including all the planets, moons, and comets within its gravitational pull. It is also astonishing that the Sun loses around 500 million kilograms of its enormous mass every second, which is converted into the heat and light we see and feel. The Sun completes its orbit around the centre of the galaxy in a period ranging from 225 to 250 million years, and has been in a constant state of activity for the same amount of time. Its surface contains atomic explosions that can reach the size of 30 Earths. These explosions throw electrical particles into space, known as the solar wind, which can eventually reach the Earth's surface. When this happens, it causes the well-known phenomenon of the aurora borealis. If the solar wind is stronger than usual, it can cause satellites to malfunction or even be destroyed. In rare cases, it can also cause power outages in many parts of the world. That's all for today. Thank you to everyone who made it this far. I appreciate all of you, and I hope you enjoyed this episode. Before you leave, please press the like button so we know how many of you made it to the end. See you in the next episode.